Hello, Fraction Camp. Okay, so this is Cuisenaire rods, fraction routines using the rods for addition, part 4. And so you can see a problem that I have placed here for the students. Remember, we've already spent quite a bit of time establishing holes and so forth. And I feel like I've done a lot of scaffolding up until this point. This might be towards the middle of the year that you start doing something as complex as this, or possibly in November. It's going to depend a lot on your routines in your classroom. Okay, so, all right, so what do we want students to be able to do? The first thing they should be saying to themselves, and you might want to provide them with frames to help them. Like the first question they might ask is, okay, so what's the value? So what is the fractional value of each of those parts, the parts that I have to add? So I want to know what is the fractional value of this and what is the fractional value of that. And that's going to be something that I need to determine using the blocks. Okay, so how do I do that? And remember, we've done quite a bit of work on creating that that routine. And so remember, okay, so here is the one hole, and I want to know what fractional value is this. Okay, so to do that, I'll compare it and say, oh, look. Okay, so remember, now I know that this is 1/3. And why is it 1/3? Well, we have some reasoning. So that's 1/3 because 3 equal parts is equivalent to 1 whole. But what fractional value is that? This is the harder part, or I would say the conceptually more challenging part. So when I look at the green, the dark green pieces, they just don't seem to line up. And so at this point, students struggle, they get confused. Some students will proclaim that it can't be done, or they'll say it's no part, or I don't know what part it is. They're going to say a lot of things. So to help them get through that, what I would say is you want to find a block that is an even multiple of the block, and also an even multiple of the whole. And so obviously I'm going right to it because I know what it is, but they're going to have to experiment a little and try out blocks. I'll give you a hint. The white blocks will always work because the white blocks are units, but they're not always going to be the least, the fraction in lowest terms. So let's take a look at this and say, oh, look, I know that the dark green is equivalent to 2 light greens, but what's the value of the 2 light greens? Well, each light green. So that's 1, 2, 3, 4, 5. So now I know that this is equal to 1/5 plus 1/5. And so now I know that the fractional value of that green piece right there is 2/5. And of course, I want some reasoning to go with that. I'm going to leave out the reasoning for now, just for the sake of the length of this recording. And so you remember, up until now, we've spent a lot of time where students are expected to be able to determine the fractional value of blocks in comparison to a whole. We've scaffolded quite a bit on that. And we've spent, in fact, up until this point, weeks, if not months, developing that skill set. All right. And now what do I have? I have 1/3. I have really 1/3 plus 2/5 is the addition problem that I'm trying to solve here. And so what will we do to try to create, to try to do that using our blocks? Okay, so we have to find a block that is common, that I can use as a multiple for each of those. Remember, at this point in time, kids are going to start to develop a familiarity with these blocks, and they should start to realize that no matter which block you have, whites will always be like every block can be created by an even multiple of the white blocks. Okay, and that's not true of any other block. Sometimes yes, sometimes no. So I'm going to say that this one is 1, 2, 3, 4, 5. That's 5 white blocks. And this one is 1, 2, 3, 4, 5, 6 white blocks. So I have 5 plus 6 white blocks. But the real question, and the question that I really want students to start thinking about is, what is the fractional value of a white block? To do that, you have to compare the white blocks to the whole. Well, we already know from our model that the orange represents 10 white blocks and the yellow represents 5. And so there's 15 white blocks in the whole. So that means, don't forget, that one white block is equal to 1/15 of the whole. So the fractional value of the white block is 1/15. So that means that 1/3 is equal to 5/15 because there's 5 white blocks. And I'm going to say plus 2/5, and that's equal to 6/15 because there's 6 white blocks. So what I really have here is 5/15 plus 6/15, and that's equal to 11/15. Put a box around it. That's the answer. Could I reduce that? That's a question you would like students to answer. I know that I can't because 11 is a prime number. And so there you go. That's the answer. Now, many of you as classroom teachers are going to be thinking about time. Of course, you have to because time is real. But you're going to say to me, but I have taught my kids an algorithmic routine for how to solve this problem. And what they will do is probably they'll do 3, 6, 9, 12, 15 like that. And then they'll do 5, 10, 15. And you'll just go to the first time that they have a common multiple. And you'll call that the least common multiple. And then you'll convert everything into 15ths. And they have a routine for doing that. Okay, but it's never clear, at least in my mind and most 10-year-old minds or 8 or 9-year-old minds, why you're doing that. Like this just seems like an artificial routine that you do, and by magic it works. So the problem is there's very little conceptual understanding. This is what I'm saying is this is very abstract, and it doesn't seem to hold much concrete meaning. And what I'm doing right here is in essence the same thing, and yet it has concrete meaning. And so what I'm replacing the least common multiple routine with finding the blocks that you can use a multiple of those blocks to create each of those larger blocks. That's the same as least common multiple. All right. So at some point, you're going to start introducing this algorithm. And then what I would like us to do is to alternate between the algorithm and the blocks until at some level, the students start to conceptually understand it. And that's the point of using concrete manipulatives, so that a highly abstract algorithm takes on meaning that they can point to, hold in their hands, and explain using their own reasoning, so that their understanding of fractions develops much more deeply.